Hi everyone. By the way, I'm Tibana Govindaraja, currently undergraduate at University of Matua, Faculty of Information Technology. Today, I'm going to discuss about the topic of pipeline hazard. When you consider about the pipeline hazards, it reduces the performance from the ideal speed gained by the pipeline. There are three kinds of pipeline hazards. First one, data hazard, which is also known as the instruction hazard. This is due to the dependency on the results of the previous instruction. Second one, hands-off hazard, which is also known as the branch hazard. As the name implied, this is due to the branching of the instructions. Due to the branching, access on the program counter will be affected. And the third one is the structural hazard, which is also known as the resource hazard. This is due to the resource conflict because hardware cannot support all possible combinations of instruction in simultaneous overlapped execution. Okay, now let's look one by one. First one, data hazard. As I have already said, it is due to the dependency on the results of the previous instruction. So, the current instruction has to wait for the result of the previous instruction. There are four types of data hazards. First one, read after read. Second one, read after write. Third one, write after read. And the fourth one, write after write. Now let's look one by one. First one, read after read. If you have seen this example here in both instructions I and J, the value of the register R3 has been read. Since this is the read statement, the value in the R3 register will not be changed. So this is not a hazard. That means issue will not be occur at any cost. Second one, read after write. If you see this example, here in the instruction I, in the register R1, the value is write back. If you consider the statement instruction J, the value from R1 register has been read. If you consider the execution of the pipeline, the 5 stages are instruction fetch, thereafter decode, third one execution, fourth one memory access, and the fifth one write back. Here, read is happening on the second stage, while write back is happening on the 5th stage. So, if this is the case for the instruction I, if you consider the statement J, instruction fetch will be begin from this. And if the decoding, that means reading of the value R1 happens here, then this will be the wrong value because it will be read before the updation. So wrong value will be read. So this should not be happen. Read should be happen after the write back in the R1 register. So read should be happen here. So in these two stages, there should be a delay. So it creates a pipeline stall or bubble. If you look at the third one, write after read, this is the rare case because of the natural structure of the pipeline. Because in a natural structure, it is with the 5 stages, and also in the second stage, read is happening, and in the 5th stage, write back is happening. So when write out after read will happen, it will happen in the pipelines for complex instruction set that support auto increment accessing and require operands to be read late in the pipeline. If you see this example here, in the SW instruction, that means storing of data, here R2 value is read and the second one at statement. Here in the R2, value is write back. If you see the execution, here reading of value R2 is happening in this stage. And in the add statement, reading of value R2 is happening here. If you divide this stage into two halves, and let's say for example, if the write back is happening in the first half, while reading is happening in the second half, then it will be the issue. Because here, the value has been read is the wrong value because it will be read after the updation. So this should not be happen. It's a hazard. Write back should be happen after the reading execution of the statement. And the last one, it is write after write. This is only present when write is happening on more than one pipe stage, or allow an instruction to proceed even when a previous instruction is stalled. If you take the example, add, subtract, and add. Here three statements will be executed. If you just think, the result of the register is needed here in the subtract statement. Okay, here value R1 is write back, so it is needed here. So what will happen is this subtract statement will be stored until the value obtained from the add statement. So if here the value should be write back in R4 register. If here also the value needed for the R1 register. So if this is the case, if the previous instruction, that means sub instruction is in the store state. So if the add statement is executed before that, then the later instruction write back is happening before than this. So the final value in the register will be the earlier statement. So it's a wrong value in the register. So this should not be happen. Later instruction value should be present at the last. Then now let's see how we are going to handle the data hazards. To handle the data hazards, we use the technique called forwarding, which is also known as the bypassing. Here, what we are done is just take these two statements as an example. In the first statement, we are adding value of R2 and R3 and store it in the R1 register. In the subtract, we have to read the value of R1. So the concept here is the value R1 is needed for the subtract statement after it is produced by the add statement. So the technique here we have to use it. We have to make it available for the subtract state instruction when it is needed. If you see this picture here, this ALU produces the result. From this, the value for R1 register will be produced, but it will not be write back, but the value will be produced. And the value is needed for the subtract statement in this stage. So what we are going to do is, we are going to directly give from the execution memory access register to input latch directly. So we make it available directly without writing back on the register. We are giving from one instruction to another instruction directly. We make it available when needed. That's the concept here. And if you take this AND statement as an example, here also the value of R1 is needed. It is needed It is needed in this stage. In this stage, the value R1 will be present here. That means in the memory access write back register. So what we have to do is, we have to give from memory write back register to input ALU directly. And if you consider this OR statement, it is needed here. But before that stage, write back will be happen. So we can directly get it for when the decode stage also. No need to give directly from that. And now let's see what are the problems also facing in forwarding statement. Forwarding works fine in the register to register instruction, because register to register instruction works really happening in the execution stage. But this is not the case for all the instructions. If you take the instructions like load instruction, their results will be available after the memory access stage, which is later than the execution stage. So, in the instructions like load instruction, forwarding helps in some cases, but it does not solve all the problems. If you see this example, this is the load statement. So here, value will be available after the memory access statement. But in the subtract statement, value will be needed here. But we can't give directly backward like that. But if you consider this AND statement, value is needed here. So here, we can give it using forwarding. We can't give it here, but we can able to give it here. So in this subtract statement, what we have to do is, we have to store. That means we have to stop the execution of the subtract statement. So when forwarding becomes the issue, we use the storing of the pipeline. What's done here is, we insert a bubble into the pipeline. So pipeline will be stored until the hazard is clear. But this is used less than the forwarding conditions, because it will increase the number of cycles required. As a result, CPR will be increased and throughput will be decreased. If you see this example here, R1 value is needed here. So until that, execution is stalled. Second one is control hazard. We will look at this from our next video. Thank you. We will meet you soon here. If you have any doubts, you can directly contact me over the LinkedIn. My LinkedIn address also Sibana Govindaraja. Thank you.